Hello and welcome back to Math with Mrs. Becker. This is Algebra 2, Chapter 1, Section 2. Today we will look at the properties of real numbers. The four basic math operations include addition, subtraction, multiplication, and division. But the cool thing is subtraction is actually a form of addition. It is addition of the opposite. And division is actually a form of multiplication. Division is multiplication by the reciprocal. And so knowing that subtraction is a form of addition and division is a form of multiplication, when they look at properties of real numbers, they only look at addition and multiplication. Kind of a cool little tip there. The first property that we will look at, it's called the additive identity property, and it's exactly what it sounds like. Additive, so we are adding. What can you add to a value so it keeps its identity? And so what that is it's a zero. The additive identity property says that the sum of a number and zero is going to be the original number. So 3 plus 0, the identity of the 3 remain the same. N plus 0 or 0 plus n. The identity of the n stayed the same. So that property is called additive identity. The next one is called multiplicative identity, and it's exactly what it sounds like. What can you multiply a number by and have its identity stay the same? Well, that's a 1. The product of a number and 1 is the original number. So 2/3 times 1, well, it's 2/3. N times 1 is n, or 1 times n is n. So anytime you multiply a value, a number or a variable by 1, you will keep the original value due to the multiplicative identity property. Okay, next one is additive inverse. Now, when you have additive inverse, again, you are adding. What you're adding are opposites. Opposites means that the number is the same, just the signs are different. One will be positive, one will be negative. So for example here, positive 5 plus negative 5, the sum will always equal a 0. Positive n plus a negative n will equal a 0. Additive inverse property. If you add a number and its opposite, meaning you only change the sign, your result is always a 0. Multiplicative inverse property. Now what that involves is a reciprocal. Remember, a reciprocal occurs when you take a fraction and you flip the numerator and the denominator upside down. Okay, and what this says, multiplicative, so I know I'm multiplying. It says the product of any non-zero number and its reciprocal is 1. So if you multiply 8 times 1 over 8, it equals 1. If I have 2/3 times its reciprocal, which would be 3/2, it equals 1. That's what the multiplicative inverse property says. If you multiply two reciprocals, your result will always be a 1, whether we're looking numerically at numbers or algebraically and using variables. Okay, so here are the first examples of the types of questions that you are going to see in your worksheet. It says find the additive and the multiplicative inverse. Additive inverse, remember the additive is the opposite. So the opposite of a positive 12 is a negative 12. Multiplicative inverse is the reciprocal. The reciprocal of 12, which is the same as 12 over 1, would be 1 over 12. Okay, the additive inverse of negative 9 over 4, additive is the opposite. So if this is negative 9 over 4, my additive inverse is positive 9 over 4. Multiplicative inverse is the reciprocal. It does not change the sign at all. So this would be negative. The denominator and the numerator switch locations. Find the additive and multiplicative inverse of 50. Additive inverse is opposite. The opposite of positive 50 is negative 50. Multiplicative inverse is the reciprocal. The reciprocal of 50 is 1 over 50. Now here's the deal. If you end up with a decimal. You do want to change it into its fraction format first, because that way I can do the reciprocal. Okay, so this is 1 over 1. There are 2 values after the decimal. That means there are 2 zeros on the bottom. So 0.01 is the same as 1 over 100. And just to make sure, you can always check with your calculator. If I go 1 over 100, I do get 0.01. Okay, so again, if you start off with a decimal, step 1 is change it to a fraction first. Now move forward. Additive, which would just be the opposite. The opposite of positive 1 over 100 is negative 1 over 100. Multiplicative inverse, that is the reciprocal. The reciprocal of 1 over 100 is 100 over 1, which is 100. So again, additive inverse is the opposite. You only change the sign. Multiplicative inverse is the reciprocal. You flip the fraction upside down. Okay, now here's a cool property, and this is one that you actually don't see too often, and it's called the closure property, and that occurs when all those other properties don't work. You're not adding a 0 or multiplying by a 1 or multiplying reciprocals or adding opposites to get a 0. The closure property means you're taking 2 real numbers and you're finding the sum or the product, meaning you're adding or multiplying, and you're going to get a real number solution. So 2 plus 3 is 5. 2 times 3 is 6. That's what the closure property is. And I will let you know, again, this is one that you don't see very often. They threw it in here so that way, if any of you were saying, well, what happens if you're not adding a 0 or multiplying by 1? What do you call it? In that case, it's called the closure property, and you just get a sum or a product that is a real number. Moving on. Okay, the commutative property, now this is really cool. The commutative property occurs when you're adding or multiplying. And what it says is that you can change the order without changing the result. So I can take 7 plus 11 and I get 18. Well, if I change the order, making the 11 come first, 11 plus 7 is still 18. It did not matter if the 7 was first or last, same as it did not matter if the 11 was first or last. As long as you were taking those 2 numbers and adding them together, the result was still 18. Same thing works with multiplying. 7 times 11 is 77. Well, if I change the order and it's 11 times 7, it's still 77. So the commutative property says you can add or multiply in any order without changing the result. The next one is the associative property. Now this one involves grouping symbols. And the way that I always remember this, the associative property, it's the groups of people who you associate yourselves with. Now what happens is if you are adding or multiplying, finding a sum or a product, you can rearrange these grouping symbols and you're still going to get the same answer. You guys, this is so cool. So let's take the top, okay? Order of operations, I would have to add this first, right? So 5 plus 3 would be 8 plus 7, so I would get 15. Now here what happened is they changed the grouping symbols, and that's what the associative property says, is you can rearrange what's inside the symbols if you're adding and multiplying. So now order of operations, I would have to add the 3 and 7 first. 3 plus 7 is 10. 5 plus 10 is 15. Notice moving the parentheses, right now it's around 5 and 3, moving it so it's around 3 and 7, it did not alter the result. Same thing with multiplying. I could take 5 times 3 first and then multiply the 7, or I could take 3 times 7 first, then multiply by 5. It will not change your result. Associative property, you change the groups of people that you associate with. You rearrange those parentheses. Next, the distributive property. Now this is a property that you probably have worked with a lot already, and as you continue to go forward in mathematics, you will use the distributive property time and time again. What this property says is if you have a value outside of parentheses, you need to multiply it into every single term. So I have to take 5 times 2 plus 5 also gets multiplied to the 8. And it does not matter if the 5 is in the front or the 5 is in the back. So 5 times 2, 5 times 8. So if you're bringing a value into a set of parentheses, you need to make sure that you multiply it to every single value that's in the parentheses. Okay, so here they are going to give us some examples of what these properties look like. What we need to do is just identify the property, okay? So this is 2 times 3.9. They're telling us that that is the same, it's equal to 3.9 times 2. So this would be an example of the commutative property, because the commutative property is the one that says you can change the order. Here, the 2 is first, the 3.9 is second. On this side, the 3.9 is first and the 2 is second. Okay, the next one. Remember, order of operations, you always do what's in the parentheses first. So this says to take 2 times the square root of 8, then times 3. This says take 3 times 2 first, then times the square root of 8. So this is the associative property, because what happened is you changed what was inside of the grouping symbols. So you changed the group of people you were associating with. You changed the group. Okay, now here, this is 9 times the square root of 2. This is the square root of 2 times 9. So again, this is just the commutative property, because all that happened was the 9 was first, now the 9 is second. The square root of 2 was second, now it's first. They just changed the order. And last but not least on this slide, this says to take 12 times pi, then multiply it by 9. This says to take 9 times 12, then multiply it by pi. What happened is they changed what was inside of the grouping symbols. When you change what's inside of the grouping symbols, that is called the associative property. So again, just some examples of what these things actually look like. Okay, now mental math. Now they threw this in just, I think it's kind of a fun little reminder. It says use mental math to find 5% tax on a $42.40 purchase. Well, this is really kind of cool. So if you have 10%, if you're going 10%, what that means is you move the decimal one place. So if I am taking 10% of $42.40, I move that decimal one location, so 10% would be $4.24. But we're not looking for 10%, but 10% is a great base. Now if we want 5%, 5% is half of that. So 5% is half of 10%. So it would be half of $4.24. So your tax would be $2.12. So what they really wanted you to do when they threw in this example is just to remember how some of those easy mental math things come into play. A big thing that I really like you guys to remember is how easy it is to work when you are taking 10%. You just move that decimal location one time, okay? Here's another example. Use mental math, so don't pick up those calculators. Use mental math to find 20% discount on a $15.60 shirt, okay? So again, I like to base everything off of 10%. So 10%, if I have 1560, I move the decimal to the left one time. So 10% is $1.56. But I don't want 10%, I want 20%. So 20% is 2 times 10%. So if I have 1.56 2 times, 6 plus 6 is 12, carry the 1. 5 plus 5 is 10 plus 1. I have the 1 down here, carry the 1. 1 plus 1 plus 1 is $3.12. So we knew that if that shirt said $15.60, if it was on a rack that said 20% off, you got to subtract $3.12 from the original price. Okay, and this is the last part of the day. They are going to give you some scenarios, and you have to say, is this statement true always? Okay, is it true always? Is it true sometimes, or is it never true? If it is always or never, it's going to fit exactly with one of our properties. If it's sometimes, you have to give an example of when it works and when it does not work, okay? So here we go. This says A times B equals A if B is 3. This is sometimes. Okay, so if I have, let's say A equals 1 and B equals 3. 1 times 3 equals 1, because A is 1. Well, that doesn't work. 1 times 3 is 3. 3 does not equal 1, so that's no. But what if A is 0? Because remember, we have that property, if you multiply anything by a 0, your result is going to be 0. So check this out. So if I fill this in, if A is 0 times B is 3 equals A is 0. 0 times 3, anything times a 0 ends up being 0. 0 equals 0, it checks. So there's an example of sometimes. Okay, now this one says if I take 3 times the group A plus 1, it's going to equal 3 times A plus 3. This is always. If it's always, you need to say what property is being demonstrated. This is an example of the distributive property. So if it's always, tell me the property that is being shown in the example. If it's sometimes, show me one that does not work, and show me one that does work. And we have a couple more just to make sure that we've got this, okay? So this says if I take A plus a negative A, notice these are opposites. They're both A's, one's positive, one's negative. It's going to equal the same as B plus a negative B. Again, those are opposites, okay? You're taking the same value. One is positive, one is negative, and they're saying that they'd be the same thing. Remember, we have that property called the additive inverse property. And what that says is if you find the sum of opposites, it's always going to be a 0. So this is always, because this is an exact example of additive inverse property. Add inverses or opposites, get a 0. Add those inverses or opposites, get a 0. Both sides would be a 0, so this is always true. Okay, last one. A minus C is the same as C minus A. This is sometimes. It's only true if A and C have the same value. But if they have a different value, this doesn't work. So for example, if A is 1 and C is 2, this says 1 minus 2 would be the same as 2 minus 1. Well, 1 minus 2 is negative 1. 2 minus 1 is 1. That doesn't work. But if they're both 1, let's say A is 1 and C is 1. 1 minus 1 equals 1 minus 1. Well, 1 minus 1 is 0, equals 1 minus 1, that's 0, that checks. So sometimes we could find an example where this did not work, we could find an example where this did work. And that concludes section 1.2. Your assignment is to complete the practice worksheets. I hope you had a great time today, and I'll visit with you soon. Bye.